This video tutorial will take a look at how to use the Pythagorean theorem. The Pythagorean theorem can be used to determine a missing side length in a right triangle. In this example, we are going to determine x. The Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the triangle and c is the hypotenuse of the triangle. 7.5 and 10 represent the measurements of the legs, because remember, the legs are the sides that form the right angle of the right triangle. So we can substitute these values in for a and for b. It does not matter which one is a and which one is b. We will substitute 7.5 in for a and 10 in for b. C represents the hypotenuse of the triangle. Remember, the hypotenuse is across from the right angle, which in this triangle is x, our unknown. So we will substitute x in for c because it is the hypotenuse. Now we can simplify each of the exponents in the equation. We will start by doing 7.5 squared, which is 7.5 times 7.5, which is 56.25. That will be added to 10 to the second power, which is 100, and that will be equal to x squared. Next, we can add 56.25 and 100, which is 156.25, and that equals x squared. To undo the square, we need to square root it. What we do to one side of an equation, we have to do to the other side. So if we square root the right side, we have to square root the left side. Now, simplifying the square root of x squared, we are left with just x. Simplifying the left side, the square root of 156.25 is 12.5. So x equals 12.5, and x represented our hypotenuse. So our hypotenuse is 12.5. We know that our hypotenuse needs to be the longest side, which if it was 12.5, it would be the longest side. Let's try another example. Notice in this example, we know one of the legs and the hypotenuse, and we're trying to find the other leg, as opposed to our first example where we knew both legs and we were trying to determine the hypotenuse. Let's use the Pythagorean theorem to find the missing length. A squared plus b squared equals c squared, where a and b are the legs of the right triangle. In this example, one of our legs is represented by the variable x, and the other leg is 3.8. Again, it does not matter which leg is a and which leg is b. So we will have x represent leg a. So we will substitute x in for a. Our other leg is 3.8, so we will substitute that in for b. Our hypotenuse is c, which in this example is 5.1. So we can substitute 5.1 in for c. Now we can simplify the exponents in the equation. X squared will remain as x squared for now, which will be added to 3.8 squared, which is 14.44, and that will be equal to 5.1 squared, which is 26.01. Now that we've simplified our exponents, we need to move forward to solve for x. To do so, we need to get rid of the positive 14.44, so we will subtract 14.44. What we do to one side of an equation, we have to also do to the other side. On the left side of the equation, plus 14.44 and minus 14.44 will cancel out, leaving us with just x squared. On the right side, 26.01 minus 14.44 is 11.57. We are left with x squared, so to undo the square, we need to square root. What we do to one side of an equation, we must also do to the other side of the equation. Simplifying the left side of the equation, the square root of x squared is x. On the right side, the square root of 11.57 is approximately 3.4. So x equals 3.4, and x represented the other leg in the right triangle. So the length of the other leg of the right triangle is 3.4. Let's try a third example. Notice in this example, We know one of the legs and the hypotenuse, and we're trying to determine the other leg. We will use the Pythagorean theorem to find the missing value. Remember, A and B in the Pythagorean theorem represent the legs of the right triangle, which in this example are x and 11. We will substitute these values in for A and B in the Pythagorean theorem. C in the Pythagorean theorem represents the hypotenuse, which in this example is 12.5. So we substitute this in for C in the Pythagorean theorem. Now that we have substituted these values in, we will simplify the exponents. X squared will remain as x squared for now, which will be added to 11 squared, which is 121, which is equal to 12.5 squared, which is 156.25. We need to now solve this equation for x. We will start by subtracting 121 from each side of the equation to get rid of the plus 121. Subtracting 121 from both sides of the equation, we will be left with x squared equals 35.25. Now, to undo the square, we will square root the left side. What we do to one side of an equation, we must also do to the other side of the equation. Simplifying the left side of the equation, the square root of x squared is x. And on the right side, the square root of 35.25 is approximately 5.9. So, x equals 5.9. So the missing measure for the other leg is 5.9.